Alright, so let's take a look at this. Remember, we're going to need this for every problem more or less, so we got to be experts at this, not just kind of good. Uh, Unfortunately, there's no Khan Academy, otherwise we'd be doing it for Khan Academy for this, because it's that important. We do it so often, we have to be experts at it, not kind of good, or I get it right when there's 3 terms but not 2. We want to get everything right all the time. Remember, what we're doing here is mostly junior high factoring. Once we have 3 terms, then we use the X, but even that's not too bad. But you guys learned way back in the day, distributed property and factoring. Just what number goes into both? Yeah, okay, 2, and is there a variable in both? Yep, same variable, and you factored it out. This is the reverse of distributed property. Show up a little more. And then just fill in, instead of multiplying, you're doing the reverse, so you're dividing. 10a squared divided by 2a. Okay. 4a divided by 2a. Nothing more, right? That's all you can do. And then when we went down to the excluded values, starting on number 5, this is exactly what we do for the excluded values. Now I will show you 2 methods. One method is this. Take exactly what the denominator is, set it not equal to 0, right? Only denominator. We don't need. Again, read the directions. Note that's the same directions from 1 through 4 on the quiz. So don't look at this and say, what can I cancel? If you read the directions first, you know, oh, this is a lot faster than all that extra work. So that's one thing we do, is set it not equal to 0. And then subtract 36 on both sides. So you have 18b not equal to 36. Divide both sides by 18. So b not equal to what? Negative something. What is 36 over 18 reduced to? Yeah, probably negative 2. Now, you might do this though. You might say, that 36 and 18, maybe you don't know 18 goes into 36 evenly. So you would probably try 9. That's what you probably would do. And you'd get 4 over 2. Now I hope you would look at that and say, well, is this fully reduced? Is negative 4 over 2 reduced all the way? You would say no. That equals negative 2. So even if you don't reduce it fully the first time through, you look at what you've already done and say, is it finished? Now here's what somebody else might do. And please write down both methods so you have them on there. You can choose and decide, well, which one gets you the right answer? Easier. My second option is to factor this. Just like on 1 through 4, factor it. So let's factor this. What's the biggest number that goes into 18 and 36? It's 18, but would you probably look at that and say 18? Once again, just like reducing the fraction, you'd probably say 9. So you take out a 9. If you know 18, then yeah, definitely do 18, but if most of us would probably do this. Just like reducing the fraction, we got negative 4 over 2. Did we say we're done because I did it one time? No, it's obvious. Same thing here. We have to look at what we just factored and say, well, 2 and 4, I didn't factor it all the way. So that's when you take out a 2. When you take a 2 out of there, you end up with the b plus 2. Now you can see where the 18 GCF comes from. And now you solve that. There's no variable here, so if I divide both sides by 18, I just get 0. So that just divides out and equals 0. So b plus 2 equals 0. Subtract 2 on both sides. b is not equal to negative 2. So Notice how we have the same numbers either method. The GCF you have to come up with when you're reducing the fraction is the exact same GCF from when you're factoring, because they're both the GCF. And it's the same problem. It has to have the exact same GCF. It's not going to have a different GCF just because I did a different method. So look at both of those. Ask yourself, well, would you rather reduce negative 36 over 18 and do it that way? Maybe you like that. However, if the directions say to simplify and find excluded values, you would want to do the right-hand column, right? Because if you have to simplify, that means you might need to cancel. You can't cancel when it's in this format. So I'd say no both, depending on the circumstances. But if anything, you look at this and you say, once again, when did you learn how to reduce a fraction? Okay, 5th grade? Notice how the numbers are exactly the same. Okay? We're not doing something that's more difficult than we've never seen before. We're doing the exact same thing. We get the exact same numbers. It looks a little different. All right, anything else? Once you work on 7. What's the excluded value for number 9?
0.
0, right? So, first thing you want to notice, there is a variable there. So that means there are excluded values for sure, right? That's what excluded values are all about when you have variables in denominator. Now there's no adding and subtracting, so you can simply just divide both sides by 30. So it equals 0. As opposed to number 10 where, well, there's no variable on the bottom. No matter what value I plug in for v, I'm never going to end up dividing by 0. Every single value of v is divided by 36. So there's no excluded values there at all. So we want to understand the difference between an answer of 0 and no answer at all. Those are not the same thing, right? Having no answers and having an answer that is 0, you don't want to say, well, they're both nothing. 0 is nothing and no answer is nothing, so they're all the same. It means two things. Okay? This has one answer, and the one answer is 0, and this has no answers at all. Alright, the rest is just factoring. How do you know when to use the x and when to... Okay. So, understand you're only using the x when you have 3 terms. And when you get down to here, hopefully you don't look at that and say, well, I need to do the x. That's just a GCF. Anytime you see something that's in common, well, I see a 3 here and a 3 here, that's a GCF. There's an x in both of them. There's a GCF. Lots of clues there for you. So please finish 1 through 13 odd right now. Checking with somebody around you, use them as the back of the book to make sure you're doing things correct. Not just writing an answer and saying, look, I'm done, I wrote something, I'm great. Okay? You have to care about doing things correctly, so use each other to help out with that. Some of you have noticed on number 6 that when you do the GCF here, you get the 9 as well as the n. Right? So in this case, you have 2 excluded values because the GCF has a variable. So we get 9n not equal to 0, so n's not equal to 0. But we also have this, right? So you get 7n not equal to 2, divide both sides by 7. Now, so we get 1, 2 excluded values. how come that did not happen over here? Right? I mean, I had a 9 in front here. How come I don't have 2 excluded values here? I had a GCF, but over here I do. What's the difference?
There's an n squared on the bottom.
Yeah, so having this variable in the GCF, that's how I know I have another answer. It's about the variable. Here it's just a GCF. I divide by 9 on both sides. 0 divided by 9 is 0. It cancels out. Over here, with the variable, I have to make it its own problem to solve. And you might notice over here, if you plug in 0 to here, you get 18 plus 36, which is not 0, so yeah, 0 is not excluded value. These are only the numbers when you plug them into the bottoms, you get 0. If you plug in 0 into here, you can see you'll get 0 minus 0. Alright, so keep on going, keep on working. Again, you want to finish, write this down for the back. On right here, you're going to have the Khan Academy assignment. Adding and subtracting. Adding and subtracting fractions. Okay, so that's going to be due at the end of class on Wednesday. Now, reminder, we only have one card of laptops, so we're going to split it up between tomorrow and Wednesday. However, I'm telling you that today for a reason. If you wait till Wednesday and then you say, well, there weren't enough laptops, I guess I don't have to turn in on time, that would be wrong. Anytime you come up with a reason, after you wait till the last second to start and then you ran out of time, that's probably going to be incorrect. So if you can, I suggest doing it at home, right? That way you don't have to worry about running out of time, the bell ringing, you have 9 correct in a row, you need 10 to finish, and then now you have to leave. That way, if you're at home, you can just get it done. So you need 10 in a row correct. They're of this difficulty. I actually had to pull up the elementary program to pull out these problems. So there's no tricks. It's actual elementary school math. Okay, nothing more. Yep. Well, yeah. So when you finish, I'll check Wednesday after school. And whoever's finished will get full credit. After that, you can't get full credit. So if you finish before Wednesday, then you don't have to tell me. I'll just look it up. Okay, right? So let's talk about the reminder on doing these. Don't want to assume anything. I found in the past to assume everybody knows how to. If I gave you a quiz right now and gave you 10 problems and said you get them all right 100%, one thing wrong is a 0%, that many would not get them all right, even though it's from the 5th grade. So I'm not going to assume that. Some of you just need to brush up because it's been a while. Others maybe didn't learn it all the way the first time, a long time ago. Who knows? So let's go through and just talk about it and make sure we understand what we're doing and why we're doing it, how everything works. So think about it like this. When you first learned fractions, you probably had pictures of pizzas and said, well, a 2 out of 7 is like a pizza that's sliced in 7 equal pieces, and you have 2 of them. And that's for the number at the bottom, that's its purpose. It's telling you how big each piece is. And the top number was, how many pieces do you have? So the size of it, and then how many do you have? And like that, you can start coming up with all these basic word problems, like if you have 4 sevenths of the pizza, meaning 4 slices out of 7, and you take away 2 slices, or you eat 2 slices, how many slices of size 7 do you have left over? We had all those conversations a long time ago. But that's why in your answer, that at the end result, it's still slices of size 7. That doesn't change. You're just counting by using the top numbers is how many of those slices. So it's helpful to understand, well, how come when you're adding subtracting, the denominator doesn't change? It's one thing just to memorize a long time ago, and, well, I just know because you don't do it because that's what I was told. Okay, but let's try to make sense out of it so it's not so much memorization, but understanding. And then the top, you got 2 minus 4. Now, obviously, back then you didn't have negative numbers and negative pizza slices, but the analogy still stands. Okay. And then when we got down to here, we said, well, we can't count up how many slices there are unless they're all cut equal sizes. Okay. It just doesn't make sense. How many slices do you have? Well, if they're not all equal slices, it doesn't make any sense to say, oh, I have 6. Maybe your slices are 3 times as big as somebody else's. So you can't compare about who really has more, who has less, if everybody has a different size slice. So that's why all the common denominator business is, if you want to find out who has more pizza or less pizza, you have to be counting by the same size. So when we have different denominators, we have to set, instead of saying, like on number 19, here we have slices of size 3, and we have 4 of them. If we just say we have 2 pizzas, how many slices is that if you're counting by 3s? Okay. So we said, well, if I have 2 pizzas and they're each sliced in 3, that means I have 6 slices of 3 altogether. And obviously, negative 6 over 3 reduces to negative 2. Negative 6 divided by 3 reduces to negative 2. Another way of looking at this is, most of the time, you are given like 8 over 4 or something like that, and you're told to reduce this. Here we're just going backwards. Instead of giving the numbers to reduce, I'm giving you the answer and telling you to go backwards. I want you to come up with something that reduces to this question. That also has 3 on the bottom. We have to have the same number, same size here. And of course, when we get to this point, what's the answer here? Okay. You gotta be careful. Is this right? 10 over 3?
No.
No. So, you know, with Khan Academy, if you do 9 in a row correct and on the 10th one you forget a negative, it's going to say start over. So we can't be kind of good at it. We still have to pay attention to algebra and make sure we get a negative in there and all that good stuff. So this is just the warm-up. If you yeah, just a warm-up, but treat this as if it's the real thing. If you can do all 20 of these correct with no help, get the right answer. When you go to do the Khan Academy, it's going to be a lot easier. As usual, though, if you go through this and write down anything that doesn't make any sense, the computer's going to tell you tomorrow real fast that you don't know what you're talking about. So don't make things up and pretend it doesn't matter what you write down, or one negative is no big deal. You have to be very concerned about doing things correctly. So show all the work, be careful with steps, and it will be easier than you think. The one thing you absolutely don't want to do is psych yourself out and saying, well, I've been avoiding fractions ever since I learned in the very beginning because they're so hard. Well, that might have been 5 years ago. Don't start this saying, well, oh my gosh, I have to do this again. This is really hard. Maybe 5 years ago when you're just learning your times tables. Don't tell yourself it's difficult now. You might psych yourself out and make it more difficult in your head than it really is. So what's the smallest number that goes in that 7 and 5 can go into? What's the LCM of 7 and 5? 35. And I can get that here by multiplying 7 times 5, so I got to be equal to the top. So I'll get 20, is that right?
Yeah.
You get negative 20. Good. And then over here, same thing. And then each of these should reduce to whatever's above it. Like 7 over 35 reduces to 1/5. 20 over 35 reduces to 4/7. And then you can get your answer. So my answer is 13 over 35, right? And the negative. I'm repeating this over and over because you get focused on doing all the fraction work, saying how easy it is, and then you get frustrated because you're not getting answers on Khan Academy. It's taking forever. It's the negatives, all right? Just be careful.